All right, welcome back to the system design series. In the last video, we looked at how to implement real-time notifications in a system. And this one, I'm going to show you just some of the code in terms of how we're going to actually implement this. And so I'm going to have four applications here running. The first one is going to be the front end itself that I have on port 5001. This is the same two-stroke engines project that we've been working on this channel for about a year now. The other one is RabbitMQ with the logging queue that I have in place. The other application is the back end of the .NET application that we're going to be using to not only publish the message to the logging queue, but also consume the message off of it and then use SignalR to send the message to the front end via WebSockets. And the other one is Postman that we're going to be just using to hit the Backend API. Also, I have VS Code open, but just with some of the front end code we'll take a look at. So I'm going to show you what happens first when I go and run this. So basically, I added code to the back end here. So if we go to the home controller, I just set up a really basic endpoint here, highlighted with the route log. Literally, all this is going to do is just take in a log message that I have defined here. So if you jump to that definition here, it's literally just a class with a message and source property. So if we go back here, I literally just have a check on the method here to check that if the message is bad, we're then going to publish a message to that log queue. The reason I'm doing that is just because in our system design diagram that if you want to see, you can go back and look at the other video. We have the log or the notification, I guess, being sent on a specific condition. So theoretically, this endpoint could be hit, 5,000, 10,000 times a minute, but we only want to send a message to our logging queue on a very specific instance. So to make it simple, I just check if the message is equal to bad. If it is, then publish it up to the queue. If it's not, then we're just going to return a 200, which is what this OK is. So if we hit this endpoint, let me just change the message. You can see that we're just going to get a bunch of returns. It's hitting that endpoint. Nothing's happening, obviously, because we're not doing anything with that data. And if we go to the front end here, the log message itself, when it gets hit, is going to appear here. So I'm going to change the message to bad. Then I'm going to send it, and you can see it appeared almost immediately on the front end. So that pretty much adheres to what we had sketched out in our architecture diagram. So let me actually pull that up here. Let me go to, what was it, notifications? I think so. Yeah. So in this example, we had the front end sending a message to the engine API, gets routed to the queue, and then to a notification service, and then to the front end. In the code I just showed you, we do everything the same, except in this case, the engine API also consumes off of the logging queue. So in my example, I just eliminated another service just out of simplicity. But in essence, it's the exact same flow. And if you are curious about a more high throughput scenario with 1 million messages sent per minute on average as a throughput, you can look at some previous videos I have when I show you the whole system with Rust and sending 1 million plus messages and showing you real-time notifications with that. This is just a simplified, scaled-down approach, but you can see that we sent a message to the front end via WebSockets. So I'm going to walk through some of that code. So if we go to the .NET backend, the actual program CS file is controls all your middleware for your .NET application. So I have mass transit set up, and I have RabbitMQ as my message broker, and I have a receiver registered right here to basically consume messages off of that logging queue, which is that. And then I have a couple configuration points set up here to basically not use any of the message headers that come along with mass transit. I just want to use the raw JSON string for serialization and also deserialization. So I have that set, and then I have a consumer registered, and the consumer is this class here. Um, Pretty straightforward. So iConsumer is included with mass transit, and it's an interface that allows you to define a method here of consume. It takes this consume context and you give it a type of log. In my case, this is the object that we want. Um, that I'm sending in Postman here, just a JSON object. It's then going to take that and do something with it. In this case, I'm literally just extracting what the message is. And then I'm going to publish it or send it to all my registered clients. And this is available um, basically with SignalR essentially. So SignalR is the .NET kind of implementation of WebSockets, and it's commonly used to handle any kind of like notifications sent to front end clients, mobile devices, anything that needs real time notification. WebSockets is excellent at, and it's near instantaneous because there's no two-way communication. It's just send it and not, there's no response. So I have a send async, and you can see that the send async says it invokes a method on the connection represented by the iClient proxy instance, does not wait for a response from the receiver. So the does not wait is really the key part there that allows this to really work as fast as it does. So if we jump to the front end code of this, you can see that I have some code set up in my React project here. So I have a SignalR connector method or function that I set up to basically establish a connection to that logging hub. And then I have right here a method called configuration called connection on, and it says registers a handler that'll be invoked when the hub method with the specified method name is invoked. So we can see that I give it a string called log received, and if we go back to my .NET solution here, you can see that they're both registered to the same thing. So invokes the method on the connection, and they're both registered with log received and log received, and this is where that message appears. So I'm getting that message because this is going to be triggered, and I'm going to set the state with the message, and that's what you see will happen on the front end. So there's not a lot of configuration. Once you get it kind of set up and kind of work through the nuances of it, implementing it the first time and then re-implementing it, I think will be a little more straightforward the more times you do it. And there's different ways you can go about this. This is just one potential way, like, a super, kind of bare bones implementation. I'm sure there's better configuration and settings you can tweak for a more production setting, but this will at least give you kind of a starting point to mess around with and see honestly really how high throughput you can make this thing. Again, I've showed you on the channel a million messages going through something just like this, and there's just no lag at all on the front end. You can build really, really powerful systems with just honestly just basic technologies like this. It just requires a little bit of configuration. Um, and honestly, there's not a whole lot beyond that. Um, we can go to my RabbitMQ queues here, and the one that we have is the logging queue. There's no messages being ready to be acknowledged because they're all consumed almost instantly. It just works really, really well. Um, I guess I can show you one more thing around this just to make it easy on myself. I do have a Docker compose file written to basically build, start my RabbitMQ container, start my um, .NET application container. This is more of just a quality of life thing for me. It just makes it easier to spin everything up in one go. Um, I guess I should go to the. Well, I guess I'm trying to think of any other configuration that I had that needs to be set up. I don't think that's. I think that's about it. I'm going to run this again just to show you in case you missed it the first time. So let's go back to log, and then we're going to send a um, message of good. It's not going to be picked up, and then bad, which is the one we checked for. You can see it appears in the front end. So again, super simplified example, but it shows the functionality. So I really encourage you to try this out. Honestly, just if you want to try WebSockets or get familiar with you know any kind of technology like that, and you want to use SignalR, um, just build a .NET web app. You can just build one of the templates out of the box that'll give you like the weather API. You can even use the templates that have the React front end. Just spin one of those up. If you do the .NET and React front end template, it'll build you everything, and you'll have a React front end that you can use to test SignalR with. So it's really really powerful. And once you get it set up, then you can just continue to add and kind of grow your skills as you experiment with things. Um, and then honestly, just see how much data you can throw at it before it lags. A lot of I found that a lot of software development is not, yeah, reading documentation is one thing, but it's a lot of experimentation just on your part, right? Just try stuff out. If you want to see what the breaking point is in terms of, you know, how much throughput can a single REST API handle? When does it run out of resources? For me, on this machine, I was seeing about 5,000 requests, per 15, what was it like? I think it started to run out of resources about 5,000 requests a minute. When I switched to use WebSockets, I was getting about a million, which is just wild. But that's the kind of stuff that, if you're familiar, with the approximate numbers, you can be, I think, in a better spot to suggest solutions. And in a system design interview, you can walk through what you've seen previously. So if you have experience with trying to scale a REST API to grow to, millions and millions of requests per minute, even per hour, per day, you can take what you've learned and say, okay, we know that there's going to be some form of throttling. So now we have to know, maybe we can introduce a queue, maybe we can introduce some new form of request routing. Maybe we can introduce WebSockets, here, something like that. And once you start thinking through, does your does your request need a response? If the answer is no, you can change your architecture around that to accommodate that. Because if you're not waiting for anything back, like you don't care if you get anything back from the data you send, then you shouldn't be experiencing latency on a system that you don't care what the response is. But again, all that stuff just takes configuration and setup, and it just takes a little bit of tweaking. But once you get it, you got it. Like you can make some really, really powerful stuff. So I'm going to continue the series. We got a lot of content to cover because there's a lot of topics on system design. Um, I, my goal with this is I'm trying to cover very specific topics in system design, but make them practical, and hopefully we'll cover some more, niche ones, because I think from my experience, it seems like, you can read a system design book, all the system design interview books are really good resources, but at some point you have to translate that into tangible things. And I'm trying to hopefully create that bridge from pure theory and put it into some kind of documented, you know, solution that people can follow along. So if this is helpful, let me know. If you have any topics that you want to see specifically, let me know. I'm probably going to do a poll here soon again because that was really helpful the first time, just to know to do a series like this. But let me know if you have any topics you want to see, or any specific technologies that we can try to look into. So anyway, yeah, thanks for watching, and I'll see you in the next.